Section 2-3, Scientific Notation and Standard Notation. Scientific notation, it's asking for you to learn the definition. And it's a way of writing very large, like going to the sun in miles, and very small numbers, like microscopic. Scientists use this a lot, hence scientific notation. It was a way to have everybody write the numbers in the same way. Standard notation is the normal way of writing numbers. So here are examples of standard form, standard notation, and scientific notation. This is a very large number, and then standard form and scientific notation, and this is a very small number. So if you're looking at these, if I'm looking at a very large number, I'm going to look at how these are formatted, and the format tells you a lot of things. There are certain ways you have to format stuff. So one, see that there's only one digit hanging out in front of the decimal? That digit has to be a non-zero digit, and just one digit. The other thing is here, notice on this one it is a non-zero and just one digit in front of the decimal. Okay, see how this 8 is a positive number? And this is a large number? That's always going to happen. And see how this is a negative, and this is a very small number with a leading 0 as a decimal and a very microscopic? That's always going to happen. Okay, here are the rules. These keys mean it is a key to your understanding and a key to knowledge. Coefficient must be greater than or equal to 1 and less than 10. That just says that this one digit, only one digit on the left of the decimal, has to be 1, 2, 3, 4, 5, 6, 7, 8, or 9, not 0, not 2 digits. This is always base 10. This exponent shows the number of decimal places that the decimal needs to be moved to change the number to standard notation. So you're going to move this decimal place. This decimal, you're going to move it according to what it is. A negative exponent indicates that the decimal is moved to the left when changing to standard notation. Okay, 10 to a positive power indicates a very large number. 10 to a negative power indicates a very small number. We're going to turn the page and we're going to practice a little bit. Okay, so writing numbers in standard notation, which means I'm given scientific notation and I need to write it in the normal way. So first you're going to go, is the exponent positive or negative? It's positive, which means it's going to be a very large number, and it's going to have commas. Okay, move the decimal point to the right or left. I'm actually going to move it that way, which is the right. And I'm going to write the number in standard notation. So 4, 1, 2, and I'm moving this decimal. It's here. That went 1, that went 2. Need to move 6. So if I do this again, the decimal would be right there. That would be 1, 2, 3, 4, 5, 6. And that is the number in standard notation. Here is the exponent positive or negative. It's negative. So there's going to be a decimal. It's going to be very small. Then we are going to put leading zeros. So I'm going to go to the left, and I'm going to do 3, 4. I'm going to go 1, 1, 2. So the decimal was here. 1, 2, 3, 4, 5, put the decimal back, put a 0. Write in standard notation. The decimal is here. I have an 8. If I add some zeros, then I start counting if I moved it right. If I didn't, I keep going. It's here. 1, 2, 3, 4. Have to add another one. And then I go back and add my commas. Negative exponent. It's going to have a 0 point because that negative exponent indicates that it's going to be a small number. So 7, 1. I'm here. I go 1, 2, 3, 4, and put a leading 0. Positive number means it's going to be large with commas. 3, 1, 4, 1, 2. So I go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8. Come back and put my commas. And that's how that is going to happen. Okay, now we're going to go opposite. We're going to go from standard notation to scientific notation. My decimal is here. I've got to get to here. It's got commas. It's going to have, what is the power? It's going to be positive because it is a large number. So I'm going to count 1, 2, 3, 4, 5, 6, 7. So it's 3.2 times 10 to the 7th. Notice I have one non-zero digit in front of the decimal with a positive power because the number has commas. Okay, 7.12. I'm going to get to right there. 1, 2, 3, 4, 5, 6, 7, 8. It's a decimal, so it's going to be a negative exponent times 10 to the negative 8th. Write in scientific notation. My decimal's here. It's got to travel all the way to here. I'm going to have 4.1 times 10 to the, this is large with commas. It's going to be positive exponent. 1, 2, 3, 4, 5, 6, 7. 4.1 times 10 to the 7th. This has a decimal. It's small. It's going to have a negative exponent. That decimal has to travel from there all the way to there. 1, 2, 3, 4, 5, 6, 7, 8. 6.43 times 10 to the negative 8. Has commas, large number, positive exponent, has to travel to right there. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1.37 times 10 to the 9th. Evaluate means plug and chug. Plug and chug. N squared minus 5, n is negative 4. Negative 4 squared minus 4. 5, sorry. Negative 4 squared minus 5. That means negative 4 times negative 4 minus 5. Negative 4 times negative 4 is positive 16 minus 5, which is 11. I box it in to show I'm done. 4x squared plus y squared for x equals 5, y equals negative 2. 4 times 5 squared plus negative 2 squared. Parentheses exponents, 4 times 5 times 5 plus negative 2 times negative 2. Multiplication division as it appears from left to right. I can do these in any order. 4 times 5 is 20. 20 times 5 is 100. Plus negative times a negative is a positive. 2 times 2 is 4. That's 104.